Hi, I'm Mrs. Paccione. I'm one of the math teachers at Wayne Valley. So this video today is for Algebra 1. The last video was made by my friend and math teacher, Mrs. Palatucci. Sometimes Ms. Hayes will also make videos. We're going to share the videos this year. And just to let you know, the lessons won't always be videos. Some days we're also going to do live lessons from the classroom, but sometimes we're going to have videos instead. So let's go ahead and get started on today's lesson. Today's lesson in the textbook would be section 1.3 or lesson 1.3. And we're going to continue our work in solving equations that Mrs. Palatucci reviewed with you the other day, but we're going to look at more complicated equations this time. So you need to take notes at home, and you should put the date on the notes. So whatever today's date is, make sure you put the date on the notes, and you want to write down these 4 steps. So pause the video to do that because that's going to take you a few minutes. These steps should look familiar because those are the inverse operations that Mrs. Palatucci talked about the other day, that we undo or use the inverse for addition and subtraction before we do the inverse of multiplication or division. So go ahead and pause the video and copy those down. Okay, so we're going to begin with our first example down here. Now, I know the lesson says that we're going to solve equations with variables on both sides. This first example actually doesn't have variables on both sides, but it does have variables in more than one place. Okay, so there's just the one variable, it's h, but it shows up in more than one location within the equation. So there's an h here, and there's an h here as well. So that's the variable that we want to solve for. So according to these steps, we should distribute first. So here's how you know when to distribute. When you have a number that's touching parentheses with nothing in between, that's when you need to distribute. If we have the same expression, but we had a plus in between, then this would not be a time to distribute. In this case, we could actually just lift out the parentheses because all we're doing here is adding this 2 in this expression. Okay, likewise, if there were a minus in front, we actually would need to do some distributing here, but it wouldn't be the 2 that we would distribute. What we would have to do in this case is realize there's what some people call an invisible 1 here, -1. And we would distribute a -1 into these parentheses. Okay, so that would become -1 times 3h, which is -3h, and -1 times -1 is +1. So when there's a number and then parentheses and no operation in between, that's when you distribute the number that's out front. And we're going to distribute that number in here. If there's a plus, we can just remove parentheses. If there's a minus, we have to remember about what some people call the invisible 1 and distributing and changing those signs. So over here in the example that we're going to look at, we need to distribute the 2. And we're going to distribute the 2 just to those first 2 terms, the 3h and the -1. We don't want to distribute to the 4h because that's not inside the parentheses. That's a separate term. So 2 times 3h is going to be 6h. And please pardon my handwriting. I'm new at using this tablet. So I got 6h, and then 2 times -1 is -2. And then I need to keep the plus 4h and the 18. Now that we're done distributing, we can look to combine like terms. In this case, the like terms are on the same side. What I mean by same side is of the equal sign. So for that equal sign, the h is here to the left and the other h is here to the left. There are no h's on the right-hand side of this equation. There are no h's over here. So in that case, you just combine them like regular old like terms. So you have a 6h and a 4h, so that makes 10h. I still have -2. And that left-hand side is equal to 18. And now we can apply the skills that Mrs. Palatucci reviewed with you the other day. We have a 10 to move and a -2. The 2 is going to get moved first because that's subtraction. So what we're going to do is use the inverse, which is addition. And we're going to add 2. We have to do that to both sides. And the reason this works is because when you have a -2 and a +2, they cancel out. They make 0, which means it just goes away. So now I have 10h equals 20, and I'm running out of space on my page. So I'm going to come up over here and copy that down again so I can take my final steps. So I have 10h equals 20. And to solve this, since I have 10h, that means it's multiplied. When there's no operation between a number and a variable, we know it's multiplication. So we're going to use the inverse, which is division. So I'm going to divide both sides by 10. I get h equals 20 over 10. And you can't leave it like that. You do need to reduce. Sometimes we'll get fractions as answers, but this fraction reduces very nicely to 2. So we want to make sure we reduce at the end. I like you guys to box or circle your final answer at the end. So if your teacher likes you to do that as well, please do that. And some teachers require that you check your answer. So if your teacher requires that you check your answer, make sure you take the time to plug that answer back in and make sure it works. We got h equals 2 here. So I'm going to take a moment and just do the check, but I need a little more space. So I erased just to get more space for myself here. And now I'm going to check that answer. And again, you only have to write down the check if your teacher requires that you need to. Okay, so we got as our answer, I started writing x. We get used to all the, so many equations have x as the variable. Sometimes we get used to those. That's supposed to be an h, not a k. Okay, so we got 2 as our answer. So what we're going to do is we're going to take this equation, and everywhere there was an h, we're going to put 2 instead to make sure it's a correct answer, to make sure it satisfies the equation. So I'm copying everything else. I copy the plus, I copy the 4, but I'm going to put a 2 here in place of the h. And just to point out, I chose right here to do 4 times 2 like this. If you wanted to write 4 and then the 2 in parentheses, that means the same thing. They both mean multiplication. You could even put parentheses around the 4 if you want. I doubt you would do that, but you're welcome to do so. It's 4 times 2 any way you do it. And then using PEMDAS, let's simplify the left-hand side. So inside the parentheses, we're going to start with that multiplication. So I have 6 minus 1. And if anyone was thinking right here, by the way, could you distribute it to 2? Technically, there's a way to do it, but I don't think you want to get involved in that. If you're checking, see how there's no more letters in here? You're just simplifying. You're just checking. Just do PEMDAS. Your life will be easier. Okay? So I have, I'm going to go ahead and do this multiplication now. And then I'm still working inside the parentheses. I have 2 times 5. I have plus 8. And that makes 10 plus 8, which is indeed 18. I like to put a check mark. That's my style, to show that the 2 sides matched and we're good to go. We have a correct answer. All right, so that's our first example. Let me slide down to our next one. Make sure you're still taking notes. Next time our class meets, I know I'm going to be asking my students to see their notes, and your other teachers might be asking you to see your notes. So make sure you're taking those notes. Okay, here's number 2. Take a moment and copy that down. You do not need to write the steps again. You already have them in your notes. I just copied and pasted them so you could see them as we work. Okay, this right here is an equation. As a matter of fact, it's called a linear equation because if you look at all the x's, see how that's an x with no exponent and that's an x with no exponent? That's how we know it's a linear equation, if there's no exponents on the variables. Later on in the course, we're going to solve equations that look like this. And I wouldn't even really try that one yet because see what's different? It has an x squared or an x to the second power. That's a different kind of equation. It's not linear. We're also going to see equations that look like this. See the absolute value there? That changes the whole game. That's a whole different lesson for a while from now. Okay, so when there's absolute value, it's not a linear. Now, I know this one doesn't have any exponents, but the absolute value is what makes it different. So just be aware of that. That's not something you're responsible for yet, but I like to bring it up at this point so that you start looking at these equations and asking yourself, are they linear? Is this what we're working on? So since this is x to the first and x to the first, there's no exponents in there and there's no absolute value anywhere, I think we have a linear equation. Okay, so the first step is to distribute. In this case, there's nothing to distribute. There's no parentheses at all, and there's no number in front of parentheses, so no need to do that. Next, we're going to combine like terms. If the terms are on opposite sides, we have to move them to the same side to combine. So you can't just do 2x and 7x and say it's 9x, okay? Because these are on opposite sides. The 2x is to the left of the equal sign, and the 7x is to the right of it. So we need to move them to the same side. Now you have 2 options at this point. Well, you have actually a bunch of options, but the two main options are you can move the 2x over here, or you can move the 7x over here. In my opinion, one of them is easier than the other. In my opinion, I would move the 2x, because if you move the 2x, to move it, you're going to subtract it. See, this 2x is positive. When there's no plus or minus in front, it's assumed to be positive. So to move it, we're going to do the opposite or inverse, which is the minus 2x. And you do that once on the left-hand side, once on the right-hand side. This makes 0, so it goes away. You're left with 6 equals 5x minus 4. And for anyone who wanted to move the 7x instead, I'm going to show you that in a moment. But let's finish this one first. Now we can use the steps from the other video. We need to undo the subtraction first. By moving the 4. And then we want to move the 5 by dividing. And we end up with 10 over 5 makes 2 when you reduce. And we have equals x. So this right here, you can leave it like that. If you'd be more comfortable making it x equals 2 at the end, feel free to take that extra step. And this is a total coincidence that this answer is 2 like the one before. The one before, the answer was h equals 2. Please do not think every equation has an answer of 2. I think you know they don't, but I wanted to mention that because that is a pretty big coincidence. Okay, now what I wanted to show you was if you take the same equation, you can start by doing some different things. So if you wanted to, you could actually start this equation by moving the 7x instead. Since the 7x is positive, because there's no sign out front, that's how we know it's positive. We're going to subtract it to move it. And I know I'm on the right track because what should happen is, see, you have 7x and minus 7x, that makes 0. That's why it cancels. This leaves me with not 4, but negative 4. Watch those signs. And here, watch those signs again. I can tell you, in Algebra 1, we're going to warn you to watch your signs over and over and over again. And you know what? We're going to keep warning you about that in Algebra 2 and Geometry and all the other math classes. It's easy to make mistakes on that. So here, this is going to be negative 5x, not positive 5x. And then we have to move the 6. Watch those signs again. And then finally, our final step to get x all by itself, because that's the goal, is to divide by negative 5. So if we divide by negative 5, this reduces, because this over itself is 1. So what we really have is 1x. We don't bother to write the x. I'm sorry, we don't bother to write the 1. We have to write the x. And then you have negative 10 over negative 5, which makes 2 for that final answer. It's the same answer. Now, if you look at these two, they're both correct. So it's okay if you do it that way or the other way. But I like this one better because if you look at, I didn't have to deal with as many negatives. By moving the 2x, see this first step here, when that became 7x minus 2x, it became 5x. It was positive, which is nicer. It's easier for me to work with. There's nothing wrong with moving the 7x, but this made a negative. So when you go to move the terms to the same side, when you have terms on, when you have the same variable on two sides, or like terms on two sides, I would try to keep things positive. It will make your life easier. You could, by the way, I'm not going to show these, don't worry, but you could, by the way, when you started this problem, you could actually move the 6 to the other side by subtracting it to start. That would be okay. You could also, instead, you could move the 4 to the other side to start. That would be okay as well. But I always like to combine the variable expressions first. So the terms that have letters, I like to get those combined up first, and then I deal with the numbers by themselves. The numbers by themselves were called constants, if you recall from the last video. Okay, if your teacher requires you to check, you can go ahead and check your answer by plugging in 2 in both places. I'm going to go ahead and continue on to the next example. Okay, and once again, you do need to take notes, so copy down number 3, but you don't need to write all those steps again. They're already in your notes. Once again, let's take a moment and look. Is this a linear equation? Yes, because if you look at the x's, there's x to the first, x to the first, and x to the first. When there's no exponent, we assume it's to the first power. So we don't have any x squareds anywhere. We don't have any x to the thirds anywhere. And we don't have any absolute values anywhere. So we have none of those types of things, because if there were an x squared or an x to the third or an absolute value somewhere, it would be a completely different kind of equation. And we will learn all those eventually in Algebra 1 and a couple of years from now in Algebra 2. But for now, we're just doing linear equations. So this is linear. And we want to take these steps. So the first step is distribute. Once again, not necessary because there are no parentheses with a number directly in front or behind it. So now we're going to combine like terms. Now this is interesting because we have a 4x, a 2x, and a minus 3x, a negative 3x. So we actually have x's on the left-hand side of the equal sign, and then we have a term with an x on the right-hand side of the equal sign. So we have same side like terms, 4x and 2x. We also have opposite side like terms because the minus 3x or negative 3x is on the other side. So you can do these in either order, but my best advice is to combine the like terms on the same side first. Please write that down. So the advice, I'm not going to write the whole thing because it would take me a long time, and with the tablet here, it wouldn't be quite as neat, but we'll go ahead and write down. The advice is combine like terms on the same side first. I think your life will be easier. Okay, so the like terms that are on the same side are the 4x and the 2x. If they're on the same side, you just combine them. So there's no changing signs. You're not gonna do this. So anybody who's thinking like, oh, I'm gonna do a minus 2x, you don't want to do that. That's incorrect. Because see how you're on the same side of the equal sign. That's a big no-no. Okay. So if your like terms are on the same side as each other, you just combine them. So you have 4x and you have 2x. I'm trying to circle them, but my circle's not quite working. Okay, so 4x and 2x makes 6x. And then you have constants. Oh, no, you don't have any constants to combine over there. I was looking at that 8, but he's on the other side of the equal sign. So I'm just going to keep the minus 7. Okay, and then I bring down the equal sign. And then over here, I have something I can combine. What I can combine is the 8 and the negative 5. Those constants make 3. And then I have a negative 3x that's over here as well. And once again, I just want to mention, because with all of these examples, there's so many different ways to do it. You could start this problem with lots of different first steps. But I think most of you will want to combine the 4x and 2x first. I think most of you want to combine the 8 and the minus 5. But just to note on the right-hand side here, so see on the left-hand side, I have 6x minus 7. When I go right over here, by the way, see how I kind of write to the side to write? You don't have to write that part down. This is just for your information in case you were looking at it differently. So see that? You could, on the right-hand side, if anyone was looking at this and thinking, wait, how'd she know to put the 3 and then the minus 3x? Like, why didn't she put the minus 3x and then the plus 3? You can do it either way. I just happen to see it as 8 minus 5, so I put the 3 first, and then I kept the negative 3x or the minus 3x after. But this would be the same. This is going to have the same answer. I just put my terms in a slightly different order. Okay? All right, back to the problem at hand. Now that we combine on the same side, we want to look at the terms on opposite sides, the 6x and minus 3x. And we want to combine those by moving them to the same side. So here's where you have that choice. Do you want to move the 6x over, or do you want to move the 3x over? Either one is correct, but I want to move the 3x over because I like positives more than I like negatives. And I bet you feel the same way. So to move the minus 3x, I'm going to add 3x. This makes 0. Over here, I get 9x minus 7 equals 3. And then this made 0, so I don't have to write plus 0 because it wouldn't have any impact. Finally, take those last two steps from the previous lesson, where we're going to move the 7 because we're going to undo the subtraction before we undo the addition. Before we undo the multiplication. And then to undo this multiplication, I'm going to rewrite this. You might want to rewrite it for your notes. It makes it a little more clear. So I have 9x equals 10. I just rewrote it because my next step is to divide by 9. And this time, when you divide both sides by 9, this reduces out because 9 over 9 is 1. So you really have 1x, but we don't usually write the 1. Okay. And on the right-hand side, that doesn't reduce. It's just 10/9. So that is my final answer. I could circle that up right there. I'm going to try to circle it without crossing it out. I did it. Okay, so x equals 10/9 is my final answer. And that's called an improper fraction. If you want to change it to a mixed number, you can. It would be it would be 1 1/9. Okay, so if you want to change it to a mixed number, you can. What I would suggest is just leave it as an improper fraction because I think that's easier than trying to do the extra step of changing it to what's called a mixed number. The only thing to make sure is just make sure you're reduced. If this could reduce, you would, but 10 and 9 don't have any common factors other than 1. So there's no number that goes into 10 that also goes into 9 other than 1. So you can't reduce it. So improper fraction is where I would leave it. If you'd like to take the extra step and make it a mixed number, you're welcome to do so. All right, that was today's lesson on solving equations when there's variables in more than one place. And we'll see you at the next class. Have a good day.